Okay guys, so I should be working here. Alright, so what's going to happen is I'm going to try and finish off the topic of circular motion. So in class we got down past these questions here. Now to try and save time, I'm just going to give brief explanations as to how things work. Now I tried doing a few video recordings where I worked the maths out as I went, but it's very awkward to work on the tablet. The tablet kind of doesn't pick up all the movements and it's just very scrappy. So instead what I will try and do is I will see can I record the maths on a separate file and then upload that file then to you on this to accompany this video. So what I'll do today is I will kind of highlight the key sections of what's left and explain them as best that I can, and then I'll do up the maths separately and show you the maths with as much information as I could put onto the maths basically. Okay, so what we're looking at today, the key one here is the derivation of the formula being, of course, this down here. T squared is equal to pi squared r cubed over gm. Okay, now what this is that's the period of the orbiting body and its relationship to, of course, the radius of said body. And that's how they're going to phrase it. So the period is basically how long it takes for the object to do a full orbit of, say, the celestial body, so the satellite orbiting the Earth, or the Earth orbiting the Sun, etc., etc. And there's a relationship between how long it takes, hence the period, and the radius at which it is spinning in. Okay, so that's kind of the key there. Now, again, knowing that, how to finish the equation is usually half the battle. So you'd have to remember that's what we're going to end up with, is t squared pi squared r cubed over gm. Okay, now it won't come out and say derivation of the formula. Okay, it'll often ask something along the lines of, I'm after leaving my pen there. Okay, so it'll usually state what is the relationship between the period of an orbit and its radius. So what's the relationship between the period t and the radius r? Okay, so the biro didn't really pick up everything there in that one, so let me rub that out. So what's the relationship between t and r? Okay, so that's kind of what they look for, is what's this relationship, what's going on between these two, how are they related? In other words, how do we get down to this equation down here? Okay, so now I've written it out in kind of horrendous English. Your English teachers will be delighted to see all this, but what I will do is I will write up the maths of it on a sheet of paper, take a picture of that, and upload that to Edmodo as well, so you can follow that. So basically we start with the two equations we already have: force of gravity, centripetal force. Okay, and if you remember from all of mechanics, F equals F. So as you can see there, the tablet not picking up my thing. F equals F. Okay, so force equals force equals force equals weight, etc., etc., etc. So all forces equal each other. Okay, so if you remember that, you can always do these derivations. So what does that mean? That means that if F equals force of gravity has to equal the centripetal force. So gm1 m2 over d squared has to equal mv squared over r. Okay, so if these two equations equate to each other, okay, then what does that mean? That means that the dm here will cancel the m here. And we can also say, well, the distance is the distance from the center of the planet, so the distance equals the radius. You see? So the two m's will cancel, and the distance d, this d squared here, equals the radius. So the distance and the radius are the same thing, because their force of gravity basically says from the center of the planet out to the object, and centripetal force is the radius, which is center of the planet out to the object. So the two of them are the same thing. So that's what we do here. That's what I'm saying down here, where we replace d squared with r squared, because it basically means the exact same thing. Okay, so therefore what you're left with is, now I skipped a step here, I'll try write it in here. So what you're left with is v squared over r equals gm over r squared. Okay, so v squared over r equals gm over r squared, which means this r will cancel with one of those r's over there, because we're going to multiply, we'll multiply this across up here, so therefore it'll cancel off one of the r's, and that's where we get this. Okay, and this is equation 1. So gm over r equals v squared. Are we okay with that? So when we equate force of gravity with centripetal force, the m's disappear. The d squared is the same as the radius because the distance, according to force of gravity, is from the center of the planet to the object, or center of the planet to center of the planet. And radius, centripetal force, is of course from the center of the planet to the object, or center of the planet to center of the planet. So therefore the r will cancel off the r. Okay, now this equation, just take note there, I have it in bold, also states that you must be familiar with v squared equals gm over r because it's not in the log tables. Now, you don't really need to learn it off because you can always work it out that way anyway. But like I said before, guys, a lot of these equations, it does help if it does help massively if you know this equation here. Okay, so if you remember this equation, there are a lot of questions that will come up where instead of what you usually do is you'll use this equation to get one value and then you'll sub it in here to get the next value. It just shortens it down where you could just immediately go straight to this equation. Okay, so it's not in the log tables. You can use it. It will make work a lot easier. Is it necessary to learn it off? No. You can figure it out without using the previous two equations. Anyway, this is, of course, equation 1. So I'm going to move this up here. So, V is distance over time, or displacement over time. Now, of course, what I mean here is we're the circumference of a circle. That is because you have your planet here, and the second object is, of course, spinning around in the orbit of said planet, you see? So because of that, we have to use 2 pi r, because it's a circular satellite orbit. They move in a circle. So anything that moves in a circle, the distance is the circumference of the circle. Do you understand? So the distance is the circumference of the circle. So therefore, I'll probably put it in here, which equals s over t, because that is s over t. So velocity is equal to distance over time. The distance, in this case, is the circumference of a circle, which is 2 pi r. So v equals 2 pi r over t. Now here, there's 2 ways to approach this next bit, okay? What I did was, I simply said, okay, let's square both sides, because we want v squared. Like, all we're going to do is we're going to sub in this v up here for this v. Okay, so we have gm over r equals v squared. I'm going to sub in that v for v squared. Hence why we end up with this 4 pi squared r squared over t squared. Okay, so if you're confused where that's coming from, I will scooch this over, give me a bit of space. This comes from, and I drew that very awkwardly, 2 pi r over t to be squared, which becomes, well, as you can see, 4 pi squared r squared over t squared. Okay, so rub out, thank you. Excellent. See, this is why I don't like using the tablet. Everything keeps coming back. Right, now, when we equate the two, how do we get from this and this to this, okay, is basically what's going to happen is when you sub in, you equate 1 and 2. In other words, what we mean is v squared equals v squared. Okay, so v squared equals v squared. Okay, so v squared equals v squared basically tells us that gm over r equals 4 pi squared r squared over t squared, and you have to make t squared the subject. Okay, so t squared has to become the subject of the formula, which means you multiply across by t squared, okay, you divide across by gm, and you multiply up by r, hence why it becomes r cubed and gm go below the line. Okay, all right, so again, I know it's awkward, but I'll have to probably write this out mathematically on a sheet of paper, and I'll take a photo of it and put it up, and it might make more sense than trying to squeeze it in here. Are we okay with that? So that's where that equation comes from. When you equate this with this, t has to become the subject of the formula, because the question is, what's the relationship between t and r? In other words, t squared is proportional to r cubed. Okay? T squared is proportional to r cubed. Okay. So that derivation is, go back over it yourselves. I'll write up a maths method without any English in it. Some of you might prefer that. Now this method as well, this equation hasn't come up for a while. I can't really think off the top of my head when it last came up. But it's generally this equation and the previous equation. And whenever circular motion comes up, they usually ask one or two. And it's usually worth about, this one is worth roughly 18 marks whenever it comes up. Okay? So it's a nice one to get. All right. Oh. So geostationary satellites. So this question comes up. Now let me see. There's no such thing as a definition of a stationary satellite. But where this question will come up, where the idea of what is a geostationary satellite comes up, is basically they will tell you that a satellite is a geostationary satellite. Now, if it's a geostationary satellite about the Earth, then what does that mean? It means it must remain over a specific spot of the Earth's surface. Therefore, it has the same time as Earth, 24 hours. And that is where it comes into play. The exam paper question will be, we have a satellite, its radius is this far from Earth, it's a geostationary satellite above Ireland or whatever. What's the centripetal force? And everyone gets it wrong, whoever gets it wrong, so not everyone, so people who get it wrong, the mistake they make is every single one of them says the same thing. Well, they never gave us the time. Well, they did. They said it's a geostationary. If it's geostationary, it has the exact same time as the planet it's revolving in, because it has to stay in the same place, you see. So as the Earth spins, the satellite has to spin. Because let's say there's a satellite above Ireland, okay? And that satellite has to be geostationary above Ireland. That means it has to be above Ireland at all times, which means it has to revolve around the Earth in 24 hours, i.e. the same way the island of Ireland revolves around Earth in 24 hours, okay? There's a full revolution. Now, period of an orbit. What does the period of an orbit mean? It means the time taken for a satellite to go once around the central body. Okay, so time for one revolution is the length of the orbit divided by the speed, 2 pi r over v. Okay, so 2 pi r over v. Now that equation, of course, comes from here. You see, we rearrange that equation. All right, so you can rearrange that equation. T goes up, V goes down. So T equals 2 pi r over V. Similarly, V equals 2 pi r over T. Okay. Again, guys, if you have any questions on this video, please don't hesitate to put them up on Edmodo, and I will try my best to explain and give my answers. All right, now, this is where the hassle will come in. So problem 7 here. And problem 8, they are in the book. They are page 144, question, and as you can see here, this marker that pen that I'm using on the tablet is absolutely horrendous. It's question 1, and problem 8 is question 7. Okay, so what I'll do, it's a bit awkward for me to try and write with this pen here. I'll get you started. Okay, and you should be able to figure it out from there. Of course, if you wish, you can, of course, work away. Now, the values that we're missing, because obviously I didn't type them in because, of course, it was just too awkward. And they're in the book. So, a satellite, so as always, look at the values we're given. Write the values out the left-hand side. Find the equation with the one missing value, and that's more than likely the correct equation. Okay, so that's what we're going to do here now. All right, so we'll highlight the question. A satellite orbits the Earth in a circular orbit, a height 50,000 kilometers. 50, I nearly said 50,000 kilometers. All right, so what we're looking for is the speed, which is v, and how long does it take to make one revolution, which is not t, it is periodic time, capital T. So not small t, capital T, periodic time. Okay? And the screen keeps moving the damn thing down, which is irritating me, but we'll just have to get over that. Right. So we list our values on the left-hand side. So what's given to us is what's always given to us, which is G, which is 6.7 by 10 to the minus 11. The radius of Earth is 6.4 by 10 to the 6 meters. The mass of Earth equals 6 by 10 to 24 kgs. We were told the height is 50,000 by 10 to the 10 to the 3, not minus 3, apologies there. 10 to the 3 meters. Because this is in kilometers, we have to convert to meters. So 10 to the 3. So you multiply this by 1,000. So it's just easier to say 10 to the 3. If you wish, you could change this to 5 by 10 to the... So we have 3 already. 4, 5, 6, 7. 10 to the 7 meters. Because, again, if you've forgotten, that's no harm. So if you've forgotten that 5 by 10 to the 7 means you multiply by 10 7 times. So we have 1, 2, 3, 4 zeros here, and then we have 3 more zeros to get it to meters. So that's why you can convert it to 5 by 10 to the 7, if you wish. It's up to you. Doesn't matter. Same answer either way. Okay? Right. So we look at our values. What are we asked to find? We are told we want V. So I'm going to leave that to V. And we want the period of time, T, which equals T. So we go and I'm just going to scroll this up here. If you go now, it's not in the log tables, but make our lives a lot easier. We can use this. GM of R equals V squared. You see? Now, you could, if you wished, use simply this. No, sorry, we couldn't because we don't have C. So we couldn't use this because we don't have FC. We can't use this because we're missing an M value. Yeah, so you're kind of stuck. Well, no, actually, you inadvertently could have worked it out. Apologies. You could simply let the two equal each other because if you copped that F equals F, which means M cancels M, and then you're left with your V squared. So actually, it would have worked out anyway. Okay, so you could have worked it out that way. Have the two equations equal to each other, and you get down to, and inadvertently you end up with this equation anyway. But of course, it's easier just to go straight to this equation. So that's what I'm going to use. So that's the first equation we'll use. V squared equals GM over R. Okay, so V squared equals GM over R. Let me check there. Is it R or R squared? R. Okay, so that's the first equation you will use, and that'll get you a V value. So please do the maths there. And the V value you should have gotten, or at least the V value that I got, was V equals 2,669.8 meters per second to the minus 1. Okay, so now that we have V, do the maths there, guys. Now that we have V, we have to find T. So of course, we can simply use the equation T equals 2 pi R all over V. Okay, we do that equation, and what did I just do there? All right, so and I got my T to be 13273.41 seconds. So what is that? 132,733.41 seconds. That's a 7, not an E. It's just the old marker is not picking it up right. Okay. So that's the values you should end up getting. Okay. Now we'll move on up to the second question. So some of you probably found that pretty straightforward. So the radius of the Earth at the equator is 6.4 by 10 to the 6. Okay. Find the linear speed of a particle at the equator and then the acceleration of a particle on the equator. Okay, so we're looking for linear speed, which goes back to earlier, where we have V equals omega times the radius. So, sorry, equation 1. Okay. Also, the values, they're the same as up here. So G is the same, mass is the same, and radius of the Earth is the same. Okay, so I just don't want to rewrite them out. So G equals 6.7 by 10 to the 11, radius of the Earth is 6.4 by 10 to the 6, mass of the Earth is 6 by 10 to the 24. Okay, so all those values stay the same. Okay, so I just don't want to rewrite them out, that's all. All right, so I'm going to scroll this up because I need all the space here. So V equals omega times R. We have R. We're trying to find V, so we need to find omega. So what is omega? Omega is equal to the change in the angle with respect to time. Okay? So, what is the angle and what is the time? I'll give you a second there to think. Can you come up with it now? So we're revolving around the Earth. So what is the angle the Earth makes in its revolution? Well, the answer to that is it goes 360 degrees because it goes a full circle. Now remember, it has to be in radians. So therefore, that is 2 pi radians. How long does it take the Earth to make a 360 degree revolution? It takes 24 hours. We have to, of course, convert that to seconds. So for each hour, 60 minutes. I'm going to ghost my house. For each minute, there is 60 seconds, which of course gets me 86,400 seconds. Okay. So when you have those two, you simply just sub those two values in up here. That gets us omega. You sub that value then back in up here. So your V value should work out to be, so do your maths, check if your answer is correct to mine. V equals 465 meters. Wait a second, just to double check there that I didn't make a mistake. I think I'm right. Yeah. Okay. Are we okay with this? I'm going to have to rub this out because I think I'm out of space. Okay, so the first question is simply get the linear speed, which is simple. V equals omega times R. What is omega? Omega is theta over t, the angle, change in angle with respect to time. 360 degrees, which of course has to be in radians, so 2 pi rad. Time is 24 hours to make the 360. So the time here is always how long did it take to make that angle? Okay, so that's the way to think about it. How long did it take us to make that angle? All right, so it takes 24 hours, which is in seconds, 86,400 seconds. Okay, so for part 2 now, so I'm just going to rub this out. So for part 2, the question is now the acceleration of the particle at the Earth's equator. Okay, so we have the linear speed. So we have that if you're at the equator, you're going to travel at 465 meters per second. Okay, so when you're standing at the equator, that's how fast you're spinning around the center of the Earth, if you will. So for part 2, what is the acceleration? Okay, so again, go to the log tables, find all the values we have, and we're told that acceleration A equals omega times R. Oh, sorry, omega squared times R. So this is very easy. We have omega, we have R, just sub them in. So A should work out to be 0.0338 meters per second to the minus second to the minus 2. There you go. Okay. Do the maths, check your work. I will take pictures of my work and put them up on Edmodo just to check if you went wrong somewhere, to see where you went wrong, or maybe if I went wrong. I mean, if you all get a different answer to me, possibly I went wrong somewhere. Now, the last thing, I know at the end of this, it does talk about past exam paper questions when it came up. Now, it's a little bit out of date because obviously it has come up since 2013, and I don't think your exam papers go back that far. So have a look at those, but there are earlier examples. The solutions to all the exam papers are up on my Edmodo page as well in the folders. The last thing I want to go through with you though, it's not in the notes there, I should already add it in. So the period of a satellite in relation to its orbit, okay? T squared equals 4 pi squared r cubed all over g m, okay? So that's the equation, all right? A question it often asks, okay, is it says, find the height. Find height of satellite. Ah, this bloody thing. E-L-L-I-T. There we go. All right, that took longer than I thought it would. So find the height of a satellite. Find the height of a satellite in orbit or whatever. Okay, so in orbit or in a geostationary orbit or whatever. Okay. Yeah, this marker is horrendous. I'm going to have to invest in a better pen if this quarantine keeps going. So basically, all this means is you have to rewrite. It's getting worse as I use it. Rewrite in terms of or. Okay? So you got to make or the subject. So whenever they ask for the height, just remember it's the radius. Okay? So to save time, you should end up with the following. Or equals the cubed root, okay, of t squared g m all over 4 pi squared. Okay, so that's how you get this equation to that, is you bring the gm up, the 4 pi squared down, and you cube root it. Okay? So I did this because a few people were asking how do you rearrange it. So if they ask for find the height of the satellite in orbit, you can actually state this as your equation to start. So you don't need to start with this, then sub in your values and get there. You could literally start in the exam with this. Sub in your values and you're done. Okay? Okay, if there's any questions, I'll try and take pictures of my extra notes and do the derivation out math style and just put it up on the thing because this is very awkward to work with. Okay?